Before solving this sum, for better understanding, refer the video of convergence of power series. Question 3c. For what values of x does the series converge? Series is x minus 3 raised to n upon n. This series is a power series. Okay. So now here we are interested to find the value of x for which this series is convergent. Okay. So that's why here we are interested to find radius of convergence r and interval of convergence. Okay. Now how to solve this problem? So this is the power series. What is the form of this series? Compare with the general form. So an x minus c raised to n form. Okay. Now here what is an? So an is what? An is 1 upon n. And here c is what? C is 3. Okay. So this is the power series. Now to find the convergence of the power series, we use ratio test. Okay. So now for ratio test, what we need? For ratio test, we need nth number of term un and n plus 1 number of term un plus 1. Okay. तो यहाँ पे आपको ये an और un में कंफ्यूज नहीं होना है. बराबर है. ये an क्या है? ये पावर सीरीज का कोफिशिएंट है. क्लियर. जबकि हम रेशियो टेस्ट में क्या यूज करते हैं? nth number of term. Okay. nth number of term of the series. So this one is my nth number of term of the series. Okay. So that's why take this entire value. So un is what? X minus 3 raised to n upon n. Now for ratio test, find n plus 1th number of term. So un plus 1 is equal to, here n is replaced by n plus 1. So we get un plus 1 is equal to x minus 3 raised to n plus 1 upon n plus 1. Okay, so this is the nth number of term. This is the n plus 1th number of term. Now use the condition of ratio test. L is equal to limit n tends to infinity mod un plus 1 upon un. Okay. Now put un plus 1. So x minus 3 raised to n plus 1 upon n plus 1 in denominator un. Okay. So after simplification, what we get? N upon x minus 3 raised to n. Now here x minus 3 raised to n and x minus 3 raised to n is cancel out. We have what? Only x minus 3 raised to power 1. And here n upon n plus 1. Okay. Here n plus 1 term, here n term. So n term is cancel out. We have one more term, x minus 3 raised to 1. So x minus 3 and separate the limit. Limit n tends to infinity n upon n plus 1. Okay. This term is free from n. Okay. So that's why we take it outside. And apply limit on this value. Mod x minus 3 limit n tends to infinity, in numerator n as it is, in denominator take n common, so we have 1 plus 1 upon n. Okay. Now this n is cancel out. Now apply limit. So mod x minus 3 as it is. After putting this value n tends to infinity, 1 upon infinity becomes 0. So 1 upon 1, so we get 1. Okay. So what is the answer? X minus 3. Okay. Now for ratio test, what is the condition? When we say that the series is convergent, if L is less than 1, then we say that the given series is convergent series. Okay. So this one is my L. Okay. So for ratio test, L is equal to x minus 3 is less than 1. Okay. Now simplify this. This is the condition of convergence of a series. Okay. So that's why we take mod x minus 3 less than 1. So now mod x minus 3 less than 1. So what does it mean? minus 1 less than x minus 3 less than 1. Okay. Now to find x, add 3 both the side. Okay. So 3 minus 1 less than x less than 3 plus 1. Okay. So what we get? 2 less than x less than 4. Okay. So we get this value 2 less than x less than 4. Okay. So this is the range of x of convergence of a series. Got it? So from this what we conclude? Radius of convergence is r equal to 1. From the definition, what is this? This one is nothing but mod x minus c less than r. Okay. This is the condition of convergence of a power series, and that we discussed earlier. Okay. So this one is what? This one is my r, and x lie in this range. Okay. So what is the interval of convergence? Open interval 2 to 4. Okay. Now next step, check whether the given series is convergent at end point or not. Okay. So check convergence at end points. So first of all, what is the interval of convergence? Here 2 less than x less than 4. Okay. So interval of convergence is x belongs to open interval 2 to 4. So this is my interval of convergence. Now next we are interested to check at end points the series is convergent or not. Okay. So first we take x equal to 2. For x equal to 2, for x equal to what to do? Now in the series put x equal to 2. Okay. So here put 2. 2 minus 3 is what? Minus 1. So we get series minus 1 raised to n upon n. Okay. So for x equal to 2, the series is minus 1 raised to n upon n. Now this series is what? Alternating series. To find the convergence of alternating series, only Leibniz test is applied. Okay. And what is the condition for Leibniz test? First condition is mod an plus 1 is less than or equal to an. Okay. For all n. मतलब कि each term is less than or equal to the previous term. And what is the second condition? Second condition is limit n tends to infinity mod an equal to 0. Okay. If these two conditions are satisfied, then we conclude that the given series is convergent series. Okay. So now first discuss these two conditions. Mod an plus 1. Okay. So here what is the an? Mod an is what? Positive term. Okay. So mod an is what? 1 upon n. So mod an is 1 upon n. And mod an plus 1 is what? 1 upon n plus 1. Okay. So as we know that mod 1 upon n plus 1 is less than 1 upon n, because here denominator is greater, okay, than n. So this number is always smaller than this number for all n. Say yes or no. Okay. So first condition is satisfied. Second, now find the limit. Limit n tends to infinity mod an is equal to limit n tends to infinity mod an is nothing but positive 1 upon n. Okay. Now put n equal to infinity. So 1 upon infinity becomes 0. Okay. So this condition is satisfied. So here both the conditions of Leibniz test are satisfied. Therefore the given series is convergent at end point x equal to 2. क्लियर? मतलब कि ये एक एंड पॉइंट पे तो सीरीज क्या है? कन्वर्जेंट है. तो हम क्या करेंगे? ये पॉइंट को क्या करेंगे? इंक्लूड करेंगे. ओके. नाउ नेक्स्ट check the convergence at the other end point. So other end point is what? 4. Okay. So now for x equal to 4. So for this what to do? Put x equal to 4 here. So 4 minus 3 is what? Positive 1. Okay. So 1 raised to n is 1 and 1 upon n. Okay. So we get the series 1 upon n. For x equal to 4, we get the series 1 upon n. How to get? In power series, put in this power series put x equal to 1. In this power series put x equal to 4. So 4 minus 3 is 1 and 1 raised to n. is always 1. Okay. So the series is what? 1 upon n. So we get this series. Now this series is a positive term series and also it is a p series. Okay. What is the form of the p series? 1 upon n raised to p. Okay. तो ये क्या है? This is a p series. Okay. Compare with p. P equal to what here? P equal to 1. Okay. And what is the condition? If p is greater than 1, then the series is what? Convergent. Okay. So, and p is less than or equal to 1, the series is what? Divergent. Got it? So here what we get? We get p equal to 1. So p is less than or equal to 1, then series is divergent. So what we conclude? The given series is divergent series. Okay. मतलब कि 4 पॉइंट पे क्या है? सीरीज डाइवर्जेंट है. मतलब कि हमें क्या करना है? 4 पॉइंट को इंक्लूड नहीं करना है. गॉट इट? सो व्हाट इज द इंटरवल ऑफ कन्वर्जेंस? क्लोज्ड इंटरवल 2 to 4. Here open interval. Because at 2 series is convergent. So that's why 2 point is included. But at 4 series is not convergent. Okay. So that's why 4 point is not included. Okay. So what is the interval of convergence? Closed interval 2 to 4 open interval. Okay. And what is the radius of convergence? Radius of convergence are equal to 1.